As you saw, that exercise went fairly quickly, and I want to emphasize this would be much more complicated in most underground mines. You would need to take these measurements in most of the airways, and the complexity increases dramatically with each additional junction or branch. So please remember this was just to illustrate the principle. Also note that the pressure differences we recorded were much smaller than you would encounter in a real mine situation, possibly by a factor of 5 to 10. This is because our fans are fairly small for the size of the hallway. I also want to mention this is just one method of performing a ventilation survey, and it's probably considered to be an older and more labor-intensive method, but it is good to have a basic one. A newer technique would use a very accurate and sensitive barometer to measure the barometric pressure differences along an airway. In the best case scenario, it would be possible to record pressures along with location data in an airway automatically. And this could even be done with a vehicle, which would speed up the work immensely. So if you do end up working as a ventilation engineer, I hope you would be able to use that method, but it's always good to know the basics. We should also point out again, if you are able to choose where you take pressure measurements, it's a good idea to choose a location with uniform bulk airflow in one direction as much as possible. Often you're not able to choose, but if you can, it will help to improve the accuracy of your model. This goes for measuring the air velocity as well. We touched on this a little bit during the anemometer traverse lab, but it's an important point that bears repeating. Okay, with all that said, we'll take a look at the results from this exercise. We recorded pressure drop data in 4 legs, starting at the fan inlet area and ending near the fan exhaust area. Again, we leapfrogged the pitot tubes, so there was always an upstream and a downstream one. The upstream pitot tube became the downstream pitot tube for the next leg. So we had 4 of those measuring pressure drops, and then we recorded the pressure increase across the fans by running one of the rubber tubes through a gap in the plywood panel to connect to the pitot tube that was located back at the starting point. Okay, so here is the data sheet. Talk from the back side. So we have drops of 2.5, 3.6, 8.5, and 12.3 pascals. Those add up to a total of 26.9 pascals. And our increase across the fans at the bottom was 28.1 pascals. So the drops that we recorded were 1.2 pascals less than the increase. That's a difference of 4.4%, and that's actually pretty good considering that some of our measurements took place outside with no boundaries to contain the airflow. But then again, we would expect the numbers to be fairly close since the air exhausted by the fans does equal the air coming in through the glass doors, but also there is probably leakage being pulled in from the labs. So I think that's a pretty good number. Again, a fairly basic demonstration, but we hope this illustrates the principle behind a ventilation survey. This is probably our last lab session, and I want to extend an invitation that when and if things ever return to normal in the future, you're all welcome to stop by the Vent Lab, go through any of these remote lab sessions in person if you would like. Advance notice would be appreciated, but we'd be happy to go through the exercises in person. That's kind of the point of a lab. I would like to congratulate those of you who will be graduating. Really sorry about the circumstances, but you'll never forget this period in history. I hope that you have fond memories of your time at NACI and UNR. I wish you the best of luck in your future careers, and I hope that you'll stay in touch. And to those of you who are not graduating, I hope to see you next fall in person in the Rock Mechanics labs for Mine 448. So good luck everybody with finals. I hope you all have a great summer, and please take care of yourselves and your loved ones. This is John signing out. And just in case you couldn't see it, I think the lighting's pretty bad. But again, congratulations everybody who's graduating, and I hope to see you guys soon.